Hello everyone, this is Martha from the Academic Support Center, and this video is going to be about exponential functions. And we've heard a lot about this recently, and they're pretty applicable to life. Exponential functions, we find them in interest rates, in the spread of disease, in population growth, and because they're so useful they show up so much in nature, that's why we want to learn about them. We can learn, and it helps us predict and understand our world. So, what is an exponential function? With any exponential function, we have a base, which here it's f of x equals b for base to the x, which the x is our exponent, or y equals b to x. F of x is just another way to say y, but we often write them that way. And something important that helps with exponential functions is that any base, it doesn't matter what it is, any base to 0 is going to equal 1. So 27 to the 0, 9 to the 0, 3/5 to the, it's all going to equal 1. And that's something important as we go along. And exponential functions will often, there's a curve and then it gets really steep like that. And to help us define what an exponential function is as well, we're going to talk for a second about what it's not. So, what is not an exponential function? And just for time's sake, I'm just going to abbreviate exponential function as EXPFUN. So if we have x squared, that's not a function because the variable is the base. We need the variable to be the exponent. So this does not equal a function. If we have 1 to the x, this is not a function. We need our base. The base must be greater than 1. Another thing that is not an exponential function is any negative number with an exponent, because that base has to be greater, it has to be positive and greater than 1. And the last instance where it's not an exponential function, where we have something of x to the x, where we have a variable in the base and in the exponent. So now we're going to go a little bit more into what these graphs look like. And we're going to start with, let's start with blue, that's a nice color. Our base can be any number, but if that base is greater than 1, as you go to the left, or it gets close to 0, it gets close to that horizontal asymptote there, and it hits at the point of 0, 1. So we're going to get close to that and then hit and go up. How steep it is depends on the base. The higher the number for the base, the steeper that slope or the steeper that change is going to happen. Now, why 0, 1? That's important to know, to use, because any x, if we take it to the 0, or any base, if we put it to the 0 power, let's say this is 1/2 to 0, anything to that 0 power is 1. So if your base number is greater than 1, this is what your chart is going to look like. Now there's something interesting when our base changes just a little bit. If our base is greater than 0 or less than 1, it looks like it kind of flips. So what is something that is greater than 0 and less than 1? For me, fractions are the easiest way to think about this. We've got 3/5, that's between 0 and 1. 9/10, that's between 0 and 1. Also decimals. If we have an exponent, or our base, sorry, if our base is 0.75. That is between 0 and 1. And what happens is as we go up to the left and down to the right. So the numerical value for our base will determine what our kind of parent function looks like for the exponential functions. So the next video, we'll talk about the transformations of exponential functions. But just quick recap, an exponential function is anything that has a base and the variable is the exponent. Any variable to the 0 is always going to, or any number to the 0 is always going to be 1. And there are times when things do not qualify as an exponential function, specifically if the variable is in the base, if the base equals to 1 or a negative number, or we have variables in both. And knowing which direction the growth goes helps us as we try and graph. So if the base numerical value is greater than 1, it's going to, on the left, it's closer to 0. On the right, it goes up to infinity. Now, if our base is a number between 0 and 1, as we go to the left, that's going to grow, it's going to get higher. As we go to the right, it's going to get closer and closer to 0. I hope this is helpful, and we'll meet again soon.